Hello, this is Prof. Mac, and you're watching the 12-3 lesson intro in 5 minutes or less. Today's learning topics will include the construction of parallel lines, angle bisectors, perpendicular bisectors, and centers of a triangle. Now, we have looked at angle bisectors, perpendicular bisectors, and centers of a triangle, but we really haven't done that in-depth of a study on them. And so we're going to take a little bit of extra time in this section to do so. All right, now when it comes to parallel lines, we're going to look at 3 different ways that you can create parallel lines using Euclidean constructions. The first 2 will be different types of a rhombus method, and then we also will be looking at the copy and angle method, or what some call the corresponding angle method, and that is actually pictured below. We will also bisect an angle, and we'll look at some properties of angle bisectors, one of which is if you take A and B, that is equidistant to the vertex or point Q. Now it also is equidistant to point C, which is an arbitrary point on the angle bisector. And what we can see here is that any point on the angle bisector is equidistant to any 2 equidistant points on the sides of an angle from the vertex. Then we're also going to look at perpendicular bisectors and just perpendicular lines. So the first thing we're going to do is we're going to do a perpendicular bisector. Then we're just going to create perpendicular lines that intersect through a line at a particular point. Sometimes it might be a point that is on the line. Other times it might be a point that is above or below the line. Our final topic that we'll be looking at in 12-3 is triangle centers. Now this is a review, but I think that oftentimes we can start to see these, but then if we don't spend enough time on them, they won't really set in. So we're going to dedicate some extra time just to do that. The biggest thing to remember is that the in-center is an angle bisector intersection. The circumcenter is the perpendicular bisector's intersection. The orthocenter is the altitude's intersection. And then finally, the centroid is the median's intersection. And we've talked a little about these before. An in-center will allow us to inscribe a circle. A circumcenter will allow us to circumscribe a circle. The orthocenter is just a special center, and then the centroid is actually the location where the center of mass of the triangle is located. So if you were to put your finger on that point, you would be able to balance the triangle on the tip of your finger. Well, that includes everything that we're going to talk about in 12-3. So this was your 12-3 lesson intro in 5 minutes or less.